Good afternoon, ladies and gentlemen of YouTube. I'm Chucky2009, and I'm here.
And this is Peter Zila with Zila Industrial Repairs, Schnetiga 77 channel.
And we are going to be running some, what is this called? Outer shield wire, 45/1000ths of an inch. And but first off, we're just going to cut out a couple of these coupons here and some backing strips. We'll have something to weld on, and we'll go from there. So now we got all our coupons prepared, and I guess we might as well talk a little bit about the wire. Pete, what do you know about this here stuff?
Wire, dual shield, outer shield. ESOP calls it dual shield, Lincoln calls it outer shield. It's a flux cord wire. It's basically a tubular wire. There's like an outer tube. The inside is filled with flux powder. And what this wire does, what the specialty of this wire is it's meant for heavy duty fabrication, railroad cars building, shipbuilding, bridges, where strength is important, but also where you have to have a little bit malleability and give in it. You don't want things to break, you don't want it to be hard and brittle, you want it to give a little bit. This wire makes deposits. They're a lot like a 7018 stick rod, and the specialty is it's welded in a spray arc transfer. It's a hot penetration, good puddle wetting, and then when you're done welding with it, it creates a slag layer on top of the bead, which helps the bead to cool down slow and evenly to prevent weld hardening or stress cracking. So 0.45 diameter, we'll load this in the machine and see what it does.
Alright, sounds good. So we'll just dig this out, and today we're going to be running it with an HTP MIG 2400. And Pete, do you have any weld parameters, settings in mind in terms of like wire feed or voltage or anything that's good starting values for this here stuff?
When I took the state certification test with this wire, the weld parameters that they gave us were 250 inches a minute and 25 volts, which is a medium hot setting, still suitable for all position welding, vertical up, overhead, but also in position. When you load this wire, make sure that we have a liner that accommodates 0.45 wire, drive roll grooves that accommodate 0.45 wire, so that we have everything ready to go.
Alright, sounds good.
The shielding gas flow on this wire should be at about 40 cubic feet per hour, 40-45, and we were using a 75-25 shielding gas with it. This wire gets welded in the regular MIG wire polarity, so the gun will be in the positive and the ground lead will be in the negative.
Pretty much exactly how you run regular, you know, solid MIG wire, short circuit.
Same gas, same polarity.
Just have to get it lined up just right. Now I'll set the tension on these drive rollers, fire up the machine, we'll pull it through and install the tip. 15-foot gun, it takes a while. Alright. That's our tip. Now we just need a nozzle and we'll be in business. What kind of stick out do you usually run with this wire?
We can refer to the Lincoln book here.
Alright.
If I'm not mistaken, 3/4 to an inch, possibly as much as 1 inch.
Okay. Wow, that's a lot. I'll just go ahead and get this handy dandy heat shield ready because I understand this is going to be pretty warm.
Outer shield 71M, spray transfer, and we will be welding in 0.45 diameter, and the stick out is 3/4 of an inch.
Wow. Alright. Sure, okay.
And at about 250 inches a minute, Lincoln suggests that you are between like 25 and 28 volts, which will result to about 160 amps. Your melt-off rate will be 5.8 pounds per hour.
That's a lot.
And you will deposit 5 pounds steel per hour.
Not bad.
Not bad. Try to do that with stick welding.
Now the last thing we have to do is get our welding parameters dialed into this nice MIG welder, and basically we're going to be running, these are approximate measurements that we took earlier. If you're curious to find out you know exactly how you can determine wire feed speed from a welder that ranges, you know, that has a readout of like 0 to 10, you know, 100%, or something like that, anything but standard inches a minute or metric equivalent. We actually made a video on how to measure this, and I'll post a link in the description if you're curious to know. But from our readout, we figured that the wire feed setting of 3 will give us about 280 inches a minute, and since we're aiming for 250, we want to be just shy of the 3 here. I'm gonna guess about there, I don't know. And we want 25 volts, right?
All right. 25 volts. You have a stopwatch?
Nah, yeah, I'll bust it out real quick.
The voltage we have to check while the arc is actually struck.
All right, that's
so
correct.
First, let's do the wire speed.
Basically, what he's gonna do is pull that trigger and hold it in for 6 seconds, and then we'll take that, because that's 1/10 of a minute, and multiply it by 10. Cool. All right, well.
I know it's just a hair too long, but let's see how much we have.
All right. 21 and a...
22 and a half. So give it a little bit more. This is 225 inches a minute. Give it a little bit more there.
Okay. Slightly more.
One more run.
One more run. Okay. Cool. Now we have 23 and a half. Oh, we got more.
We got like 24 and a quarter. Good enough for me.
All right, that's going to be close enough. Great. Well, now let's do the voltage. As you can see, our approximate settings here indicate that we'll have to have the main voltage on 4 of 4 and sub voltage on 4 of 6. So basically what I'll do is I'll just head over to the welder here. We are at 4. Actually, it happens to already be set like that, so we'll be fine. All right, well, I guess now it's time to make some tack welds, or just weld for a second or two.
Yeah, let's get a test piece and let's see what the actual voltage readout is.
On the machine. All right, excellent. Now there are ways you can get a good voltage reading if you don't have a digital readout like this HDP does, and that's also covered in that other video that I mentioned. Really? That's up for 25 or 26.
Check it up one more. The book says 25 to 28.
Okay. Alright. We just gave him one more notch of voltage. There's 28, 27. It's ranging 27 to 28 on the lower end of 27. We'll also have to crank up the fume extractor.
That's good enough, yeah.
That's good?
We will have to crank up the fume extractor.
Alright. We'll just come over here, fire up this nice Avani SPC 2000.
Alright, this is the test coupon. This material here is 5/8 of an inch thick. It's hot rolled 1018 flat stock, 5 inches wide. In a test situation for a state certification, this material would be as much as 1 inch thick, and it also would be 6 inches wide.
Okay.
After filling this all in with weld, there's 2 strips cut out of it, and they're bend tested. And there's a certain allowance for imperfections, but it's not much. It cannot break. If there is imperfections in there, there cannot be any cracks originating from any pinholes or slag inclusions. So the key is, this is a 1G weld. This would be a 2G weld. This would be a 3G weld. And this would be a 4G weld. It has to be welded and clean in position. It cannot be moved. Once it's like tacked to the table or like vertical up, this is where it has to stay.
Alright.
So what we will do today is we start with the 1G and fill this in here. There's a 1/4 inch open root in there. So we will fill this with weld, multiple passes, weave passes, and we'll be using a neutral angle or a slight push angle.
Okay. He's going to be going in there pretty much perpendicular, maybe with a slight push. Hang on. Alright. I'm going to reposition this foot first. And one other thing before we begin, let's have a look at all the safety gear that Pete's wearing. He's got the helmet with probably a darker shade than he uses for other things, I guess. We got the safety glasses, we got the heavy coat, and these gloves with the heat-resistant backing.
Yeah, flux core is hot. It's spray arc, it will be hot. With a short neck gun like this, it will be really hot on your hands. I can only recommend wear long sleeves when you weld flux core.
Alright, here, let me get it. Position here.
To chip the weld and see if we did any good.
Alright. Look at that, it just comes off.
Yeah, we did a nice clean weld, no pinholes. The toes are nice, wetted in. And now to fill this, we have two options. We can either continue with weave passes, but the weave passes cannot be too wide, or we can run stringers down and stack stringer on top of stringer. So let's go to town.
All right.
To try not to weld over the slag, but you can stack passes next to each other or have like a third overlap and still be okay.
Okay.
See how easy the slag peels off? Once you have heat in the part, the slag comes off really easy.
That is awesome. It's basically like the love child of stick and MIG welding. Stick welding from the spool, looks like.
All right, let's put another few passes in. Sweating, how the puddle is really washing out of the, how the puddle is really washing it all out of the material. It would look somewhat like this.
Okay, do it.
at the wire not feeding correctly when you saw it burning back more. One out of two things. Either my contact tip to work distance was too short, everything heated up, and the wire was binding in the tip, or the drive rollers were slipping. We're using V-groove drive rollers here. We should use some knurled drive rollers with a little bit tread that feed the wire nicer. This tubular wire, besides that it's really slick, it's also really brittle. You can break this off without side cutters to restart.
Very nice.
Now let's see what this looks like.
Definitely a ginormous flux core weld.
Yeah. This is about the widest you can go. From now on, you have to put half passes in. Half pass up here, half pass up there. Legally, you're only allowed to go so wide.
Okay. Sure, cool. Alright, YouTube. I've never done this before, but I'm willing to try it and post the results on the internet anyway. Once I figure out how this here heat shield thing works. Alright, I think we're good.
How did it feel?
That was awesome! Short Circuit MIG has officially left the building, and this is something completely different. That was a lot of fun. Alright, go ahead, deslagify this. Well, for having never done this before, it looks like it's sagging a little bit. Carrying over my stick welding experience, that would tell me I should move faster across the center, I think.
Yeah, go faster across the center.
Faster across the center.
Stay about a second, second and a half on in each corner, and just go fast over the center.
Alright. Well shoot, I'll try it again. Ready?
Yep.
This is pretty awesome, YouTube. That is very, very hot welding. This is probably not something you'll use to put together 1/8 inch sheet metal. Alright. Well, look at that. We're starting to get somewhere.
Yep. You are.
A little bit different looking.
Let me put one more pass in it.
Sure. Whenever you're ready.
Ready.
26 point something volts. And about 150 amps. How was that?
That was awesome. Nice and tight.
That is a huge weld.
Here, watch this.
Oh man.
All
look at
comes
that.
off in one piece. There you go.
That's a souvenir. We can put it on eBay.
You should really wait till it's like not glowing anymore to chip it to get the full benefit of the flux core wire.
Okay. Wow, that is a big weld.
Now your interpass temperature on this is supposed to be not any higher than 800 degrees. As long as it's still glowing, it's too hot.
Okay.
Alright, after letting it cool a little bit by itself, nobody touched it so far. You can see the slag peeling off all by itself.
Oh man, look at that.
Nice ropey beat.
Woo! That is a ginormous weld, YouTube.
This is nothing yet.
Jeez.
This on 4-inch material, that's a ginormous weld. we do 5/8 every day. 5/8 does not make our heart beat faster.
Oh man. So you have like a welding shop, or?
I have a welding shop in Milwaukee. We do a lot of welding for the recycling industry, big balers, shears, compactors, excavators, and anything like 1/2 inch and up, crane booms. Those are the things that we weld. 3 service trucks, engine drive welders, and...
Alright. If anyone needs some welding done in the Milwaukee area,
call us.
Alright. You want me to put some information in the description or link to anything?
Sure. Put a link to my website in it.
Okay, cool.
Alright, ladies and gentlemen. This is the weld. This is the end of the weld. We cut the upper half off with a cutoff wheel. Then we cut a strip about 3/8 thick. I know this is not exactly up to AWS D1.1 welding certification specs. The plate thickness is wrong, the groove angle is wrong, the plate width is wrong, but nevertheless it gives you a nice demonstration of the wire, and it's really similar to what would have to be done for a state certification.
Yep.
We cut this piece out of here, cleaned it up, removed the backing strip. Now we have to flatten the front weld out, and then we'll bend test it.
Alright. So yeah, the good old vise is getting some use, and you know, like you said, this might not be exactly up to code qualifications, but to be fair, we're really just messing around with some of this dual shield wire, making a general, you know, basic information video about it, and we're gonna bend test it anyway, because why not? So we got our handy dandy Harbor Freight bender. And we are bending this fine specimen. Oh boy.
And we almost bent it where the weld was.
Yeah, shoot. Well, we can slice out another one.
Wow. This is where the left side of the weld was. And here, this is what I meant with allowable impurities. There's 2 little pinholes, but no crack originated out of it bending. No cracks on the backside. So, most likely, we would have passed the certification test.
Alright, cool. Alright, so Pete had to head back. The guy worked an entire day before his trip out here, drove through the night to get here, and then proceeded to shoot videos with me for almost an entire day because sleep's apparently optional for him. I don't know, but anyway, I've gone ahead and sliced out a couple more of these side bend tests. And for anyone that's never done side bend, basically, you know, it's a form of destructive testing, obviously, commonly used on thicker steels. I believe this is a 1-inch block I stick welded. And, you know, you can't really bend something that's 1 inch thick that easily. So what they do is they slice out normally a 3/8 inch coupon, 3/8 inch thick, and then you bend it over itself, and it pops out the weld and whatever little defects may be on it. And so that's basically what we're trying to do here. Now the one that y'all just saw us bend sort of came out a little bit like a candy cane. There's something of a trick to getting these lined up in here just right, and I don't really know what that trick is because I pretty much never do this by myself. Okay, I can see where the root is. I obviously didn't really sand down the sides that, you know, we're not going to be bend testing. So there's the root, and I'm going to put this on top and try to aim for the center of that doohickey there. Alright, I hope this works. I'm going to slide out this handle. Oh no, someone left the tripod here. Okay, that one looks relatively U-shaped. Whee-wee! We hit most of the weld. Alright, I'm going to try the other one. Pulling it through. Nope, I was afraid of that. Well, I hit most of the weld. I think I'm going to practice with that bender a little bit more. But as you can see, there's the root. Yeah, look at it this way. It looks a little bit better. And here's the face. You can see where they were because I obviously didn't completely grind them flush. And this is the part that I did grind flush. And when you look at it, all you see is the grinder marks. There's nothing popping through. There's no cracks, defects, and trapped slag. Nothing along those lines. It's just pure weld metal. So, you know, I guess we can call this test a success. And, you know, like we said, this isn't exactly up to AWS standard, so to speak. Basically, Pete and I were talking one day, and I was like, yeah, I've never run any of that dual shield stuff. And he's like, really? It's awesome. I'll bring some down with me. And so he did, and we're like, well, you know, we obviously had to come up with some kind of video to make about it. And we just decided to put together a redneck bend test from some scrap metal, you know, just laying around here. And that's what we came up with. So anyway, I hope you guys have enjoyed the video. As always, YouTube, thanks for watching. Don't forget to rate, comment, and subscribe for more. A big thank you to Pete, aka Schlee Tiger. I think I'm getting better at that. As always, YouTube, thanks for watching. Don't forget to rate, comment, and subscribe for more. Have a nice day, everybody. Yeehaw.